Thank you so much for the invite. And I took this opportunity to present one of the work we have recently published with Huawei. And so if you need to know more and have more details on what I'm presenting now, the best way is just to download the paper. It's about 40 pages work. Okay. So are those slides visible?
Yes.
Yes, it is.
Yeah, so I've been in this information communication industry for about 25 years, and my experience has been both as an industry player and as an academic, as I like to do that. And industry player, most of the time, I have spent in Nokia and Huawei technologies, and main contributions, and my main contribution has been on mobile communication systems, especially 4G, 5G, and its evolution. Now, going into the subject, so how can we apply artificial intelligence to improve performance or the degree of automation of 5G system? There's a lot of work ongoing, and some of the presenters already covered very important topics, and including the definition of artificial intelligence, which I found a lot, say in the literature, confusing. But one of the best definitions I found is from the European Commission, and they make it crystal clear what we are talking about. And these slides represent, in high level, the concept. So usually we speak about artificial intelligence systems. So, and we talk about software or hardware that they act in the physical or the digital dimension in order to achieve some preset or given goals. And we have three main categories of applications. We have robotic platforms, reasoning systems, and in particular, I think of relevance nowadays is machine learning, booming in the direction of deep learning, but also reinforcement learning. Now, in the paper, we also go into the detail and we describe all the algorithm methodologies. So machine learning categories, we do have three main categories: supervised learning, unsupervised learning, and reinforcement learning. And I had a chance to look into two main categories of those, so the supervised learning and reinforcement learning. And here you have a summary and examples of different type of models and applications. Yeah, you do have a lot of results now coming with the implementation of artificial neural networks. There are many flavors. I've seen a lot of results and successful deployment using a recurrent neural network. Whereas I've tried even to work together with my son to look at the possibility of deploying reinforcement learning approach to optimize, for example, the lights, so the traffic lights. There is a lot of traffic coming, and so my son investigated the possibility of deploying the reinforcement learning. We compared that with evolutionary approach, and finally it demonstrated that evolutionary approaches are performing better than reinforcement learning algorithm. And the reason is that if you go into the details, you very hard time to find a policy that links, given a set of observation of states, that links the state itself to the possible action. So you spend so much time in this complexity where, say, a genetic algorithm has already solved the problem much more efficiently and effectively to the reinforcement learning. But that's, of course, just the experience I've had into that direction. And there could be other examples performing much better. Now, just an overview of what what's happening in the standards. And you have a lot of work in 𝗬𝗎 and the initiative within the experiential, there's a typo, yeah, the experimental networked intelligence. And that team, what is doing at the moment is to develop an architecture and the functionalities, including interfaces and the parameters, is changed to enhance the model of MANO. So the management orchestration platform that has been developed by 𝗬𝗎 and now broadly adopted in terms of virtualization. What this initiative is about is to provide services to the orchestrator in the hope that the orchestrator, by receiving input using artificial intelligence, could further improve the placement of the different function depending on the performance of the corresponding application. Another initiative already presented by the earlier speaker is ongoing in IITU. I found that a very comprehensive work. So the IITU FGML for 5G systems, they go really into the details and they come out with an interesting concept of machine learning pipeline. And also, if you look at their documents, they really found the gaps and what we need to do and standardize in order to have a massive adoption and of the machine learning for 5G systems and beyond. So they introduced the concept of pipeline. You have a number of nodes, and each of those nodes has a well-defined role. So they start from the source where the data coming from, and then you have a way to collect this data, pre-process the data, and in order to aggregate them and make them usable by removing biases or anything that would introduce just an overhead. And then you have the model itself and the policy, and then you do have a distribution node. And finally is the sink where the inference takes place. It's a very comprehensive model. It remains to be seen how the 3GPP technical specifications will incorporate this concept, in particular how this plane, which is nothing else than a new plane, we work together with the current management plane as well as the control plane and the data plane. So a lot of work to do. And as you can see from the standards, if you have a look at what the GPP has done currently for release 16, which is expected to be finalized as we speak now, and I had a look at the technical specification is empty, but they have attempted at least to bring together a number of use cases and a high-level architecture, which is to me far behind what the IITU has proposed. So that's a standard. Then if you look at the industry is going well forward, I will show you some example of deployments. So those are the typical use cases. We are expecting this network data analytics function now introduced in the standard with different interfaces. So you can see our interfaces to the OEM, so the management system, the application function, including the MEC, but also other functions of the core network. There's nothing here about in the standard about the RAN, whereas the TMF, Telemanagement Forum, already they are thinking of extracting data, of course, from the RAN. Those are the use cases. And if you look at the use cases in detail, we are especially after measurements. Measurements, so that means path recognition, where you can find nicely the application of neural networks, deep neural networks as an example. So yeah, for analyzing the end user experience behavior, quality of service, congestion situation. For example, I've worked a lot into customer networks, and the recurrent neural network were used to predict traffic. So if you are able to predict the traffic in the network, you're going to save a lot of money. Now, just a couple of slides about what is ongoing in the standard, in the industry, and this is in particular what is being done within my organization and other organizations. They have for sure an equivalent approach. That's an high-level architecture, and you can see here You need to have functionality deployed all over the places. So from the physical layer, then you will need to have the corresponding function and inference platform within the upper layer and the corresponding network domains from RAM, the transport network layer separated from the core. And finally, you need to find a way to have a consistent provisioning of the model that you're training. And currently the training is done by reporting data to a public cloud. Why? Because usually you need to have access to a lot of data, and public cloud, then you may expose your capabilities to third party and create a marketplace to offer AI as a service, not only to develop algorithm and model to push down to your network elements. So where are we today? So the broad aim in the industry, within the academia, but also in the standards, as we've seen earlier in my presentation, is to shift. So like the model is to say, okay, look, like cars, we are driving cars, and the expectation is by maybe 2040, something like this, there will be plenty of autonomous car, possibly connected. So we are moving from something that it is manual, operated manually, to something that is fully autonomous. Autonomous means that there's no human intervention, and also the platform, it is a robotic platform that wouldn't need even connectivity. Today, if you look at the network and the AI application to mobile communication system, we are pretty much at level 2. So we do have a partial autonomous network. So there is a lot of work to be done in front of us. And the approaches are usually following specific scenarios. So we don't have a solution to all problems, but usually what we look into are possible scenario. Here, you have example scenario for network planning design, network construction, network optimization, performance improvement, and network operation and management. And different colors means different type of application. And then on the left, you have the different type of network domains. And you can see most of them are around virtualized platform cloud computing. As I said earlier, it is because there where you have a large degree of freedom to make measurements, to inspect the performance and orchestrate by reinforcing or re-embedding the functions depending on the expected performance. It could be latency, it could be throughput, it could be load, and so forth. So that's basically a high-level view of the different applications, from construction down to 5G network slicing, and then data centers. There are a lot of results already available. Of course, there are proprietary solutions. Proprietary means that's not just proprietary the algorithm itself, but it's also proprietary in the instruction of the information, the inference, and the provisioning of the model into the network. These are just a couple of examples. One looks into the optimization or improvement of performance of massive MIMO in terms of coverage. And there are many parameters. So you do have your algorithm for beamforming, which has, it is constrained by the formulation you're having in creating that particular pattern. What we do on top is we look at the possibility of further improving the parameters. And what we have achieved here is massive coverage improvement, both consider the vertical plane and the horizontal. The other typical application, it is intelligent analysis of logs, alarms, and call chains. Why? Because what is especially business viable is to improve the troubleshooting of the network. So the correlation of what defaults or other type of alarms have in the network, and then link that to corresponding action and possibly avoid site visits. Another problem that's now coming is, I want to mention here, more covered into the paper, is the security So how, what are the new problems coming? This is just an example considering deep neural networks. If you are after reinforcement learning is even more complex, the situation, because you are in closed loop with a variety of more data, including having algorithm in the terms of reinforcement learning. But that's just an example to give you a flavor of the new problems coming and the corresponding mitigation actions. So the new problems are just a few of them. I'm listing here, like because of the problem is that after the explicability of the model itself. So what we should have in front of us to be in a position of mitigating the risks, we should be able to have an explicable model, which means a model that is transparent and also support accountability. Transparency means we need to have an understanding of what that particular algorithm is doing. Accountability means that if something's happening, you can root cause and trace what the problem, where the problem were originating, and you can fix them. So if you don't do that, and if you don't have very good quality software, you end up to having many, many vulnerabilities. So like example of backdoors, or many kind of attacks can be embedded in there. So we need to have a way to have a very, very clear algorithm and quality software. Data integrity as well, because if you look at the process itself, it encompasses a lot of data at rest and a lot of data in transit. Any data at rest and in transit may be compromised. So we can compromise in terms of poisoning the data, and we can compromise the corresponding integrity. So we need to have integrity and confidentiality in place so that those particular risks can be mitigated. The same thing applied to the model robustness, because if the model itself is improperly trained, or say negatively affected by an intruder when it is deployed at an inference platform, then basically all algorithm ends up to be compromised. In addition to this, we need to pay attention to data privacy, because by simply querying a model, a lot of information can be extracted, including the PII, so the information related to privacy. And that's pretty much what I want to share with you. I was recently interviewed, there is an interview, and I'm explaining more about cybersecurity. So we are in front of us a lot of new things coming, and many challenges, but I think overall the 5G, and I think especially its evolution, maybe from release 17, 18 and beyond, people that are already thinking of 6G, we will see, I think, the mix of one additional plane, that is the artificial intelligence plane that the IITU describes, in addition to the traditional plane, user plane, control plane, and management plane. Thank you.